Okay, let's start. Uh, in the last class, we discussed about uh, drawing projections of points and lines. Okay, and actually, we would continue learning about projections of lines, but a new topic we would learn, which involves another additional topic or another additional plane called an auxiliary plane, or one or more auxiliary planes. Uh, so the so this would be our last class regarding projection of lines. Okay, we have done plenty of thing with projection of points, but now we are into projection of lines, and uh, that we would do today. And from next class onwards, we would move on to drawing projections of solid objects. So basically, surfaces and solids, those are we are going to project afterwards. So so let me first give you an example. Acha, in the last class, I gave you some assignment from the book that I was following. Uh, I gave you problem set 6.1, 6.2, and 6.3. Uh, Today, we would start solving one of the problems from 6.4. Okay, and we would just use one example. Okay, and we would see how we can solve that example. Okay, and that's the only thing that we learn today. Okay, and please pay attention while we are discussing things. And you know, the this today's discussion is actually is supposed to develop your concept. So please pay attention and ask if you have any question. Okay. Okay, so in the problem set 6.4, okay, and I'll take the first example. It tells me that the coordinates of set of points are given somewhat like this. B is this coordinate. Okay. Okay, so the thing is, you are supposed to construct projections of lines AB and CD. That is number one. And the next thing that you are supposed to do is to determine whether they intersect. Okay. Okay. So is the problem statement clear to everyone?
Yes, sir.
Okay. So These are like the x, y, and z coordinates of each of the points. And if we can, standardize how we are supposed to show one of the points, let's say on the front view and the top view, okay, then we can figure out how we can, draw the lines in the two projections. And it's only two projections that we need. Okay, so imagine this is our x-axis, this is our y-axis, and this is our z-axis. So the plane xy plane is our HP, or the horizontal plane. The xz plane is our vertical plane, or VP, and our profile plane, which we can, skip for the time being. We don't need the profile view right now, which would be, let's say, YZ plane. Okay, we can take it like that. Okay, and let's take the example of C, because it is in the, the first quadrant. All coordinates are positive. So if we take C, so it says that it is 10 10 millimeters away from the YZ plane. This value means it is 10 millimeters away from the YZ plane. Okay, and the next coordinate 30 tells you that this is 30 millimeters ahead of, or in front of, the vertical plane, and then it is 25 millimeters above the horizontal plane. Okay, so 10 from, so this dimension is 10. Okay, this dimension is 30, and then on the vertical plane, sorry,
স্যার ক্লাসটা কি রেকর্ড
sorry,
স্যার ক্লাস কি রেকর্ড করা যাচ্ছে না?
ক্লাসটা কিন্তু আমি রেকর্ড করছি। আই এম রেকর্ডিং ইন এ ডিফারেন্ট সফটওয়্যার, আই এম নট জাস্ট এবল টু ডু দ্যাট ইন গুগল মিট।
আচ্ছা, আচ্ছা। তাহলে স্যার কি প্রেজেন্ট অ্যাটেন্ডেন্সটা দিয়ে দেবো চ্যাট বক্সে?
হ্যাঁ, অ্যাটেন্ডেন্স দিতে পারো।
ওকে স্যার।
Okay, so now we have the third dimension, which represents the distance from the horizontal plane, and that is 25. And that way you get the point C. Okay, now uh, when you take the top view of C, that is 30 millimeters in front of vertical plane, and 25 millimeter, sorry, 10 millimeters, you can say, in front, or 10 millimeters away from the profile plane. Okay, and so this is the top view, and this is going to be the front view of the same point, which on the vertical plane would look like it is 10 millimeters away from the profile plane as usual, and 25 away from the horizontal plane, or on top of, or above horizontal plane. Okay, so again, now we are constructing. So once we take projection, what do? we would just rotate the horizontal plane and make it align with the vertical plane. Okay, so let's say these are the, I mean, these 2 points, uh, I mean, these are not coordinates x and y. The xy line that separates between the vertical plane and the horizontal plane. And if you need better representation, you can go with, let's say, AB. You can call this line as AB. Okay, then you're also pointing, or maybe you can call it PQ. That would suffice because you're supposed to draw these points, right? A, B, etc. Now, now you do not know where you are supposed to draw the profile plane, okay, or rather, where should be the origin. You can imagine, you can imagine some line, okay, some line as the representation of the profile plane. Whether you are taking projection on the vertical plane or the horizontal plane, the profile plane looks like a line, okay, and which would essentially represent the zero value for x coordinate, okay, which would correspond to the zero value of the x coordinate, okay. Now, point A lies on point A lies on 5 millimeters 5 millimeters away from the profile plane. So 5 millimeters away from the profile plane, you can draw another line. All of these lines are your construction lines, so they should be as I mean, it doesn't matter even if they are not visible. Okay, so this line you should have in your mind more than you should have in your drawing sheet. But if it is on the drawing sheet, it should be lightly traced, and the main purpose is to plot those points. Okay, now the y coordinate mm, says -10. That means it is not in front of the vertical plane but behind the vertical plane. So the top view, okay, so this is the top view in the first angle. So the top view is supposed to be over here, 10 units over here. So this much is 5. Then let's say this much, actually smaller than that. 10. Okay, now I'm just showing the dimension like this, but this is how you are supposed to do. Okay, also, while dimensioning a vertical line, your dimension should go like this. Okay, because we are using the aligned method of dimensioning. There is one other method which is unidirectional, and unidirectional would require you to have the middle portion erased, and there you would put your dimension. Okay, and whether you are putting a vertical or a horizontal dimension, it's the text is always aligned in the same direction. Okay, now I'm doing this thing for the sake of simplicity, so I can demonstrate how the drawing should be done. This is extremely rough work, okay, and this is not how you should be doing in your drawing sheet. What we discussed later is how you should be doing it on your drawing sheet. Okay, so somewhere over here, so if this is C, the front view, let's call it C prime, the top view is C double prime. So this is where we would get A double prime. That is the top view of A. So it is actually on the horizontal plane, but then you rotated the horizontal plane and it lied on the negative y side of the horizontal plane. That's why it kind of aligned itself with the vertical plane. Okay. Now that is just the top view. For the front view, that lies 10 millimeter above horizontal plane. Okay. So the thing is, for A, the front view and the top view, they are actually coincidental. Okay. Now you might be confused, or in a way I kind of wish you are confused, which means you are paying attention, that how this happened. So would you like me to clarify how this happened? The front and the top view are coincidental.
Yes, sir.
কেউ আছো যে বুঝতে পেরেছো? আচ্ছা. So the thing is, if I do the same exercise with the vertical plane, with the horizontal plane, okay, and this is the extended portion of the horizontal plane, that is on the negative y side, okay, and point A, as it turns out, lies uh, behind the vertical plane by 10 millimeters. Okay, so if this much is 10 millimeters, so this is where on this dotted line lies the projection of A on the horizontal plane. For the vertical plane, sorry, uh, for the vertical projection or the front view, the point A actually lies 10 millimeters above, 10 millimeters above the horizontal plane. So point A is somewhere over here, where its vertical projection, or the point A is actually 10 millimeters above the horizontal plane and 10 millimeters behind the vertical plane. And somewhere over here, let's say, is the vertical front view, sorry, the top view of point A. Let's say A double prime, and this one is A prime. Achha, I made a mistake by calling it A triple prime. It should be like A prime, the front view. Okay. Now, as usual, if we, after taking the projection, if we rotate the horizontal plane and make it align with the vertical plane, what happens is this uh, top view of the point A actually aligns itself with its front view. So its projection on the horizontal plane makes it align with its projection on the vertical plane, and that's how the same point represents A double prime and A prime. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now you repeat the process for different points. For example, C would lie on a line which is, if we refer to this as the 0, okay, so it would lie 10, uh, 10 millimeters in front of that, and it is this much in front of the vertical plane, 30 millimeters. So if uh, this much is 30, so this is where you have the projection for C double prime. So C is this much, 30 millimeters in front of the vertical plane. So on the horizontal plane, so this side is your horizontal plane and this side is your vertical plane. So on the horizontal plane, its projection is here. On the vertical plane, it is 25. So let's say this much is 25. Okay. Now let's look at B. B is, as it suggests, 30 millimeters in front of the profile plane. And let's say that is represented by this line right here. And for D, which is 50 millimeters in front of your profile plane, you can take it to be over somewhere over here. So for B, it is minus 15 and 20. So just like A, Y coordinate is negative and the Z coordinate is positive. So for B, it would be, let's say this much is 15 and this much is 20. So 15 it is 15 millimeters behind the vertical plane. So its horizontal projection is given by this point, which is 15 millimeters above PQ. And its vertical projection or front view is 20 millimeters above the line PQ, which is B prime. Okay. So is it clear how the projection of B would turn out to be, or should I explain? Should I draw a different diagram for B?
Understood, sir.
Okay. Let's try the same for D. So D is 50 millimeters in front of the profile plane, but then it is 20 millimeters behind, so behind the vertical plane, which makes this one as the top view, and then it is 5 millimeters above the horizontal plane. So this makes the front view. Okay. Now our job is to join line AB and CD in the two different projections. On the top view and the front view, I am supposed to join the projections. Okay. So how I should be joining? If I am joining AB on the front view, then I should be joining A prime with B prime. So on the front view, the line looks like this. And on the top view, the line would look, okay, it's actually the same point. Okay. Similarly, for C and D, so this is how CD looks like on the front view, and this is how CD looks like on the top view. Okay.
Yes, sir.
Okay. So does this make sense up to this part?
Yes, sir.
Yes, sir.
কিছু কি বোঝা গেল কি হচ্ছে এখানে?
হ্যাঁ স্যার, কিছুটা বুঝতে পেরেছি।
এখানে কোনো কনফিউশন নেই তো কি হলো? কারো কোনো কনফিউশন নেই? আচ্ছা, যদি কারো কোনো কনফিউশন না থাকে তাহলে এটা কি বলা যাবে এখানে ইন্টারসেকশন হচ্ছে কিনা লাইন দুটো? আমার কথা শোনা যাচ্ছে?
হ্যাঁ স্যার, শোনা যাচ্ছে।
আচ্ছা।
মানে এই ডায়াগ্রামটা দেখে কিরকম বলবো সেইটা বুঝতে পারছি না।
হ্যালো?
হ্যাঁ স্যার, শোনা যাচ্ছে।
শোনা যাচ্ছে। তো এটাকে আরেকটু ক্লারিফাই করে দিই, আমার মনে হয় এই মুহূর্তে হয়তো এটা একটু কনফিউজিং রয়েছে। আলাদা করে থিঙ্ক অফ দ্য লাইন C prime A prime, which is kind of a line like this, and then think of the line D prime, sorry, not C prime A prime, B prime A prime, and then think of the line D prime C prime. Okay. If you draw the just the front view, if you draw just the front view, okay, uh, it looks like there is a point of intersection, but the two lines are on three-dimensional space, okay, and which might look like a point of intersection on a projection may not actually be an intersection itself. Okay, so uh, now the top view, how does the top view look like? So this is the line BA, and this is the line CD. Now, of course, my drawing is actually only representative, not accurate. Okay, but it seems to me that once you draw the top view, okay, the lines no longer intersect, the projections no longer intersect. Okay, and if there was an actual intersection between the two lines, can we agree then what in whatever plane we take a projection of, okay, in whatever plane do we take the projection, the projections will always intersect. Can we agree to that? So this is what the top view is going to be, and this is what the front view is going to be. এইটা কি বোঝা যাচ্ছে কি বলতে চাইছি?
Yes, sir.
একদম সবাই ক্লাসের মধ্যে চুপ করে গেছো। আমি দেখো, মানে ইন পার্সন ইন্টারাকশন করা যাচ্ছে না। তো আমার এটা বোঝা দরকার তোমরা মানে ইন্টারেস্টেড নও সেইটা কি ঘটনা, নাকি তোমরা বুঝতে পারছো না? না বুঝতে পারলে কোথায় অসুবিধে সেটা যদি একটু বলো। আর যদি ইন্টারেস্টেড না থাকো সে তো আলাদা কথা, ক্লাসে থাকারও দরকার নেই।
মানে স্যার ডায়াগ্রাম গুলো যে ড্র করা হয়েছে ওগুলো বুঝতে পেরেছি, এবার আপনি যেটা জানতে চাইছেন যে এর টপ ভিউ আর ফ্রন্ট ভিউ দেখে আমরা বলতে পারবো কিনা যে ইন্টারসেক্ট করবেই কিনা, সেই ব্যাপারটা ঠিক বুঝতে পারছি না বলে কিছু বলিনি, চুপ করে গেছিলাম আর কি।
দুটো লাইন যদি ইন্টারসেক্ট করে, can you imagine looking at those two lines from any angle? So what does the projections mean? It means that you are looking at an object from different angles. That's what it means. The different views are essentially that thing only. Okay, you are looking at it from the top or looking at it from the in front or behind or side. Those are projections, right? Literally those are different views, different in angles in which you look at it. But যদি বুঝতে অসুবিধা হয়, টেক ইউর ফিঙ্গার্স, দুটো হাতের দুটো আঙুল নাও। ওকে, টেক ইউর ইন্ডেক্স ফিঙ্গার্স, তর্জনী, দুটো আঙুলে দুটো তর্জনী নিয়ে মেক আ ক্রস সাইন অ্যান্ড ট্রাই টু লুক অ্যাট ইট ফ্রম এনি অ্যাঙ্গেল। ওকে, try to look at it from any angle, and the fingers, uh, you know, the angle between the fingers might change from different angles. Okay, uh, the angles may be distorted. Okay, but the intersection is always there in whatever view you look at it, in whatever angle do you look at it. Okay, if the two lines do intersect, okay, it is also a possibility that two lines do not intersect. They are non-coplanar lines. Okay, there are two ways two lines can make a uh, two lines could be coplanar. They could be parallel, or maybe they are either extended or non-extended. They should be intersecting. Okay, but
Yes, sir.
Yes,
yes,
sir.
but if you take this projection, okay, these two projections, এখানে দুটো জিনিস খেয়াল করো। If I were only given the top view, okay, I can say that the lines are not intersecting, number one, but they could be intersecting if, let's say, the line AB is extended. Okay, এই পার্টটা বোঝা গেল? If I am just given the top view, it could have been the case that the lines do not intersect as they are, but if the line AB may be extended, they could be intersecting. Okay, that could have been a
Ye-
possibility. ঠিক আছে?
Yes, sir.
Yes, sir.
That could have been a possibility.
Yes, sir.
But the moment I am given another view, front view, where the projections do intersect, that made me conclude that the lines do not intersect at all. The three-dimensional lines of which the projections are being drawn, they do not intersect at all. কেন আমার মনে হলো? সবার আগে মনে রাখতে হবে, দুটো স্ট্রেট লাইন যদি ইন্টারসেক্ট করে, ওকে, the intersection can only happen at a single point. Do you agree or not?
Yes, sir.
Yes,
Can a
sir.
pair of straight line intersect in more than one point? No, right?
No, sir.
No, sir.
Okay. Now, when I take projection of a straight line, what do I get? The projection is also a straight line. Do you agree to that or not?
Yes, sir.
Okay. Achha.
Yes, sir.
Just a minute ago, we were discussing that if the two lines do intersect, okay, so in any angle or in any plane, if we choose to get the projection, the projections will also intersect. এটাও মানা যাচ্ছে কি যাচ্ছে না?
হ্যাঁ স্যার।
মানা যাচ্ছে তো?
আচ্ছা।
তাহলে যদি এটাই ঘটতো, that if I extend the line AB if I extend the line AB, okay, and then there would be an intersection between line CD and AB. So there would be an intersection point which is beyond A and B. Okay. Then after that extension, if I had drawn the front view, I would be getting two intersection points between AB and CD. এই স্টেটমেন্টটা কি বোঝা গেল?
স্যার আরেকবার বলুন।
হ্যাঁ, টপ ভিউটা যদি শুধু দেয়া থাকতো আমরা কনক্লুড করতে পারি দুটো জিনিস, that either the two lines do not intersect at all, that means the two lines are non coplanar, দুটো লাইন দিয়ে একটা প্লেন ভাবা যাবে না, ঠিক আছে? দুটো একটা লাইন আর একটা পয়েন্ট or তিনটে পয়েন্ট or তিনটে ভার্টেক্স দিয়ে একটা প্লেন ভাবা যায়, ওকে, but two lines have to be coplanar in order for you to be able to construct a line which contains both. So if I just been given the top view, I can conclude two things. One, either that those two lines are non-coplanar, they do not intersect at all, neither are they parallel. Parallel janoy, that is obvious. Number two, there could be an intersection point, let's say by extending AB. Okay. So of course that point of intersection would happen either on the A side or B side, that is beyond the domain of AB. Okay. But the moment I am given the front view, and in the front view the projections, not the line themselves but the projections of the two lines, they intersect somewhere between A and B. Then this is a thought experiment. Then let's say if our second assumption were true from the previous view, that is top view, that if we extended the line AB, there would be a point of intersection between AB and CD. Okay. But imagine, I mean আমি যেটা বলতে চাইছি যে let's say there is no point of intersection, but if I extend AB to, let's say, ABE, and this, then E double prime is on the top view, and there could be a point of intersection F double prime that would be visible on the top view. Okay. But on the front view, that F prime point would be somewhere beyond B prime, and that F prime cannot be the same point of intersection that we see on the front view. Okay. Because you see the projections of lines are also straight lines themselves, and two straight lines can intersect only at a single point, because the point that we are thinking of, which we would get by extending AB, okay, that cannot be the same point of intersection as the one that we see on the front view. Okay. Because we have also established that if two straight lines do intersect, the projections would also intersect on any plane or any view. Okay. But since this F point is supposed to be on the extended AB, so this doesn't necessarily lie on AB or between A prime and B prime, and that's why our assumption that such a point F exists is incorrect, which basically means these two lines do not intersect with one another. এটা কি বোঝা গেল?
ইয়েস স্যার।
হ্যাঁ
আচ্ছা বোঝা গেল।
আচ্ছা, নাও আমি তোমাদের 6 এর দাগের 6.4 এর যতগুলো প্রবলেম আছে সবকটাই অ্যাসাইনমেন্ট দেব। ওকে, অ্যান্ড হিয়ার উই স অ্যান এক্সাম্পল, যেটার ক্ষেত্রে আমার অন্তত যেটুকু আমরা করলাম, রাফলিও যেটুকু করলাম, তাতে মনে হচ্ছে যে জাস্ট বাই ড্রয়িং দ্য টপ ভিউ ইউ উড ইমিডিয়েটলি নো দ্য lines do not intersect. Okay, or even the extended portion of the lines do not intersect, you would know that. Okay, but that may not be the general situation. Okay, how do we do for, I mean, mm, simply from the front view and the top view one might not know that whether or not there is intersection of the lines or not. Okay, so so there may be other planes in which we need to take our projections, and I'm not talking about the profile plane. I'm talking about planes which are not necessarily orthogonal to rest of the planes. Okay, see, there could be only three planes which are all orthogonal to one another. The profile plane, vertical plane, and horizontal plane, they have already been drawn. Now we are talking about something called auxiliary planes. Okay, and now you would need, for a general problem, we would need auxiliary planes. Okay, and when I'm drawing an auxiliary plane, okay, to uh, mm, to analyze the projection on a given plane, so that auxiliary plane is only going to be perpendicular to that given plane. ধরো তুমি ভার্টিক্যাল প্লেনের যে প্রজেকশনটা অর ফ্রন্ট ভিউটা সেটাকে ইন্ট্রোস্পেক্ট করবার জন্য you are drawing an auxiliary plane. So the auxiliary plane is supposed to be perpendicular to that vertical plane, to the vertical plane, but not necessarily perpendicular to horizontal plane or profile plane. Okay, so আমরা একটা এক্সাম্পল নিই. Okay, and that would make the things clear. Now before analyzing whether there is an intersection or not, let's see how we can find the true length of a straight line. Mane, if I am giving you the coordinates of let's say okay, from that you can actually use your calculator and find out the true length, the length of the straight line. Okay, acha, what is true length and what is not true length? True length is basically the actual length of the straight line. Okay, so the true length is essentially this. Okay, but I'm on a drawing sheet we are not allowed to use a calculator. Okay, we'll have to find out the true length from the projections themselves. Okay, number one. And number two, the word true length is in context to something, and that context is that what you are drawing on either the front view or the top view or the profile view are all projections, or any other plane you are drawing projections of a line. Okay, and those planes are none of them necessarily either orthogonal or parallel to those lines. Okay, now you can have different planes and on which you can have the projection of a given line, and the length of the projection is always smaller than the actual length of the line. Okay, so the maximum value that the projection length of the projected line can be is that of the original line or the true length. Okay, so we are trying to actually not looking for the length value. Of course we are looking for the length value, but rather we are looking for a plane on which we can have a projection okay, which has the same length that of the line. Can you tell me what is the condition for that?
So please repeat once.
Yeah. So there is line AB of which you can find out the length. But I am asking you to give me a plane. If I were to take projection of the line AB on that plane, the the projected line, let's say A prime B prime, would have the same length as AB. What is the condition for that?
Sir, if the line is parallel to the plane.
Parallel to the plane. That's it. No other condition. Correct. So let's say this line corresponds to x1 and this line corresponds to x2. Okay. Now y1 is is how much in front of vertical plane is point A. So there goes your y1, and this is your z1. So this is your A prime and A double prime. Okay. And similarly, assume this much is your z2, and this much is your y2, let's say. Okay. Now I would draw a line RS. I would draw a line RS which is parallel to, let's say, the projection on the vertical plane or the front view of the line AB. Okay. And this RS, you can imagine perpendicular to your vertical plane and passing through this line, there is one plane. So you imagine this is your vertical plane, and this is the projection of the line AB on the vertical plane. Okay. This is the projection. The actual line is, let's say, something like this. Okay. Okay. Now RS is a plane RS is a line, okay, which is parallel to the projection A prime B prime. Now imagine a plane which passes through RS and is also perpendicular to the vertical plane. So a plane which passes through RS and is also parallel to the vertical plane, okay, which basically means, sorry, not parallel to vertical plane, perpendicular to vertical plane, which basically means is these two edges are perpendicular to the vertical plane. Now this is our auxiliary plane. And this auxiliary plane, can I say this is also parallel to A, B, B prime, A? See, because I am drawing parallel lines, that is A prime is parallel to B, B prime, then I can say A, B, B prime, A forms a plane. Okay. So this thing, the line itself and its projection forms a plane. And RS is parallel to A prime, B prime, and it is the other two edges of this plane, or this plane is perpendicular. See, this is an orthogonal orthographic projection. So these lines are also perpendicular to the vertical plane. Okay. So all I'm trying to say here is this plane, this auxiliary plane is actually parallel to the line AB. It is parallel to this entire quadrilateral or this entire plane, which also means this auxiliary plane is also parallel to the line AB. Can you agree on that?
Yes, sir.
Can everyone agree on that?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now let's see what we can do. Now what I'm doing is I'm dropping perpendicular. Again, these are construction lines. Should be as thin as possible. Okay. And extend those lines. Now this distance A prime is what? A prime is the is how much? So you need to understand that A prime is actually perpendicular to V, the vertical plane. Also A prime represents how much, by how much point A is in front of V, or in other words A prime is y1. Do you agree with that? That's why on the top view or on the projection on the horizontal plane, you get to say this y1, and also you get to see the y2, because those represent the distance from the vertical plane. See,
Yes, sir.
any plane which is perpendicular to vertical plane will allow you to capture the distance of the point from the vertical plane. এই পার্টটা কি বোঝা যাচ্ছে? You cannot capture the distance from the vertical plane on the front view, because the front view is on the vertical plane. But if you take projection on any other plane which is perpendicular to vertical plane, you will be able to capture the distance of the point from the vertical plane, the normal distance.
Yes, sir.
Do you agree to that?
Yes, sir.
So now
Yes, sir.
this y1 represents the distance from the vertical plane. So take y1 from here. and this, take this y2 from here. Okay, and then join this. Actually, it's not going to be parallel. Okay, so then you are going to get AB. Okay, then you are actually going to get AB, not projection, but AB itself. You are going to get the true length. See what is happening here. You see this auxiliary plane here. Okay, I'm taking the projection of the line AB on that auxiliary plane by taking the distance from the vertical planes, because those are the ones that are going to be captured. And then again I'm rotating this auxiliary plane, okay, about RS. Okay, about this line RS, I'm rotating this auxiliary plane and aligning this auxiliary plane with the vertical plane. Okay, and why am I dropping perpendiculars? I'm dropping perpendiculars
To get the
yeah
full
so
length.
to get the distance between A and B parallel to the vertical plane. Okay, so you see, this is the idea. If I first project AB on the auxiliary plane and then project that projection on the vertical plane, okay, because the entire auxiliary plane, once projected on the vertical plane, matches the RS line, the projection of AB on the auxiliary plane, okay, would also be matching the RS line. Okay, and that projection of AB on the vertical plane, when you first took the projection in the auxiliary plane and then taking the projection on the vertical plane, okay, should be same as the projection of AB, because this auxiliary plane is supposed to give you the true length. So first I'm taking the projection of AB on the auxiliary plane and then taking the projection of that projection on the vertical plane. Two-step process. The other one being directly taking projection of AB on the vertical plane, which is a single step process. In both cases, I'm supposed to get the same projection or the same length of the projection. So to maintain that same length, what I'm doing is dropping perpendiculars. Okay.
Yes, sir.
Okay, sir.
Okay. See, why am I claiming that in the two-step process and the single-step process am I supposed to get the same projection? It's because the auxiliary plane that is represented by RS, that is supposed to give me the true length of AB. Okay, that's why when I first project AB on RS, I still get AB because I get the true length on the on that auxiliary plane. So for and then when I project on the vertical plane, that projection on the vertical plane is supposed to be exactly same as if I were to project AB directly on the vertical plane. Just to maintain that thing, okay, I'm dropping this perpendicular. Okay, I could have done this also. I don't even have to have perpendicular. I could simply be drawing two parallel lines from here. The only thing that I need to maintain is height of point A should be y1 and height of point B should be y2. Then also I'll get the same projection, or then also I'll get the true length. Okay, but I'm dropping perpendiculars uh, because I mean that is how we plot the top view and the front view, right? So these are two orthogonal planes, and the two projections A prime and A double prime are on the same vertical line. Similarly, we are doing for A prime and A as well. Okay. Yeah, I think it should be perpendicular only. But it seems that even if you did any other angle and drew parallel lines, there also it would work. Anyways, now what do I why do I need the true length? Okay. Now think of a plane on which uh, you are not getting the true length. Okay. On that plane, if you take a plane, so just like RS, I am taking another auxiliary plane. Let's say TU, an auxiliary plane. Okay. And let's say this TU is perpendicular to the projection A prime B prime. Okay. Now a plane, if parallel to a straight line, okay, so we just learned if there is a plane which is parallel to a given straight line, okay, that plane would simply look like a parallel line when both the plane and the line are projected on a plane to which this parallel plane is perpendicular to. Okay. Now imagine this is the projection of the line on the vertical plane, and now you are drawing or thinking of an auxiliary plane which is perpendicular to vertical plane, of course, because that's why you are drawing on the vertical plane. But then it is perpendicular to the projection, not to the actual line, but to the projection. Okay. So that means on that plane, A and B would be plotted on the same line. So how would the lines look like? So OI1 for A prime and Y2 for B. So let's say this one is A triple prime and this one is B triple prime. Okay. So since the top view, front view, or the position on the vertical plane didn't give me the true length, so when I take another auxiliary plane which is perpendicular to that projection, I get some arbitrary view in which A double prime and B double prime are lying on the same vertical line. Okay. But if I have a plane on which I am getting true length, then if I drew another auxiliary plane on that auxiliary plane, okay, so let's say VW plane, let's say this is a VW plane, okay, and this VW plane is not only perpendicular to the auxiliary plane that has the true length, but it is also perpendicular to this true length projection of AB. Okay. And as usual, we took the projection on that second auxiliary plane and then revolved that auxiliary plane to align it with the first auxiliary plane RS, then rotated all of them together to align with the vertical plane as usual. Now what will we get? Again, I'm dropping perpendicular. You need to remember that the projection of A and B both would lie on the same line. Okay, because this entire line, this projection is perpendicular to this plane. Now, in the second auxiliary plane, we are supposed to plot the distances of the line of the points A and B from this first auxiliary plane. But how much is the distance of the points A and B from the first auxiliary plane? You see, the first auxiliary plane was drawn to be parallel to the line AB, or the projection A prime B prime, which basically means if this distance is h1, this distance is also h1, which basically means this time the projection of the line becomes a single point. So you are looking at this is like the auxiliary plane 1, and this is like the auxiliary plane 2. So in the first auxiliary plane, the plane itself is parallel to the straight line, hence you are getting the true length. Now on that auxiliary plane, you are imagining another plane which is perpendicular to the first auxiliary plane. Not only that, it is also perpendicular to the projection of the line on the auxiliary plane. But the line itself is parallel to the auxiliary plane, and what you have as a projection, that is actually the true length of the line, which basically means this time this second auxiliary plane is actually perpendicular to the straight line itself. And when you project a straight line along a plane which is perpendicular to it, you basically get a single point. এই পার্টটা কি বোঝা গেল এই অবধি?
ইয়েস স্যার।
Yes, sir.
সবাই বুঝতে পেরেছো যে আমরা কি করে ট্রু লেংথ পাবো, ট্রু লেংথের পরের স্টেপে আমরা কি করে একটা পয়েন্ট পাবো প্রজেকশনে? সবাই বুঝতে পেরেছো? কেউ নেই বুঝতে পারোনি? কারোর এতটুকু কোনো কনফিউশন নেই?
স্যার এই মাঝখানে এই ট্রিপল ড্যাশ ওই পার্টটা বুঝাবেন একবার?
কোন পার্টটা বলো?
এই ট্রিপল ড্যাশ।
আচ্ছা
স্যার এখানে
দেখো, আমরা এই যে ফার্স্ট অক্সিলারি প্লেনে প্রজেকশনটা এঁকেছি, ওয়্যার উই হ্যাভ দ্য ট্রু লেংথ, ঠিক আছে? এবার একটা জিনিস বলি, if some plane is parallel to given straight line, আমরা যেটা দেখলাম, if we take the projection of the line on that plane, we get the true length. ওকে, এটা তো এক নম্বর কথা। দু নম্বর কথা হচ্ছে, the projection which we get as a true length, that projection, the projected line, that also becomes parallel to the original line. ওকে, কি বলতে চাইছি সেটা দেখো। ধরো এটা একটা প্লেন, আর এই লাইনটা ডেফিনেটলি এই প্লেনের সঙ্গে প্যারালাল না, বাট ওয়ান্স ইউ ড্রপ পারপেন্ডিকুলার্স you get this projection. Now obviously AB is not parallel to a prime b prime, এটা বোঝা যায়।
হ্যাঁ স্যার।
বাট যদি এটা হতো, you are projecting it to a plane which is parallel to the line itself, then the projection is also parallel to the line. এটা কি বোঝা যাচ্ছে? The
হ্যাঁ
projected,
স্যার।
হ্যাঁ স্যার।
okay. Now consider this one to be the auxiliary plane 1. On this plane I am taking another plane. On this plane I am considering a plane which is perpendicular to this auxiliary plane. Not only that, that plane, the second auxiliary plane, is perpendicular to the projection a prime b prime. Now by virtue of the fact that AB is parallel to a prime b prime, okay, so this next auxiliary plane that I am imagining, that also becomes perpendicular to AB. এবারটা বোঝা গেল?
হ্যাঁ স্যার।
এবার AB এর সঙ্গে পারপেন্ডিকুলার কোনো একটা প্লেনে আমি AB কে প্রজেক্ট করছি, কি পাবো আমি? আমি একটা পেন্সিলকে তার লিডের দিকে তাকিয়ে দেখছি, so it essentially looks like a point to me, right?
ইয়েস স্যার।
ইয়েস স্যার।
এইবার বোঝা গেল কি বলতে চাইছি?
ইয়েস স্যার।
সবাই বুঝতে পেরেছো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
হ্যাঁ স্যার।
এবার আমরা প্রথমে ট্রু লেংথের গল্পে গেলাম, তারপর আমরা প্রজেক্ট করে পুরো জিনিসটাকে একটা পয়েন্ট বানিয়ে দিলাম, ঠিক আছে? এটা করে আমার কি সুবিধে হলো? সুবিধা যেটা হলো, এই এতক্ষণ ধরে একটা লাইনের ট্রু লেংথ, একটা লাইনের পয়েন্ট ভিউ ইত্যাদি করলাম, ঠিক আছে? এবার একটা সেকেন্ড লাইনকে ভাবতে শুরু করো। ধরো এই গল্পটাতে প্রথম থেকে একটা সেকেন্ড লাইনও ছিল, নানা রকমভাবে তার প্রজেকশন দেখা যাচ্ছে। This distance equals this distance, and this distance equals this distance, ঠিক আছে? তাহলে সেকেন্ড লাইনটাকেও আমি একইভাবে প্রজেক্ট করতে করতে যাচ্ছি। যে প্লেনটাতে অক্সিলারি প্লেন 1, যেখানে আমি একটা স্ট্রেট লাইনের ট্রু লেংথ ভিউ পেলাম, সেখানে তার অন্য কোনো একটা ভিউ পেলাম, সেকেন্ড লাইনে আমি অন্য কোনো একটা ভিউ পেলাম। এই ট্রু লেংথ ভিউ পর্যন্ত, if I do not see that at any point the two lines are not intersecting, এই জিনিসটা যদি আমি কখনো না দেখি, তাহলে অব্যর্থ ওষুধ হচ্ছে পরের স্টেপটা। সেটা কি? পরের স্টেপে আমি আবার প্রজেক্ট করলাম। আমি প্রজেকশন লাইনগুলো সবসময় ড্র করব হচ্ছে যে প্লেনে প্রজেক্ট করছি তার সঙ্গে পারপেন্ডিকুলার। তাহলে আমি এই প্লেনটাতে চলে গেলাম, ঠিক আছে? এবার আমি কি করব? এবার হচ্ছে যে আমি যে ডিস্টেন্সগুলো নেব সেটা হচ্ছে এই যে আর এস লাইনটা, এটার থেকে ডিস্টেন্স কত, ঠিক আছে? সেই ডিস্টেন্সগুলো আমি এখানে ইউজ করব। যদি এটা সি, এটা ডি হয়, তাহলে সি এর জন্য হচ্ছে এতটা ডিস্টেন্স, ডি এর জন্য হচ্ছে এটা ছোট ডিস্টেন্স, সরি এখানে না, ডাব্লিউ ভি লাইনের এদিকে, তো এটা হচ্ছে সি এর জন্য, আর ডি এর জন্য হচ্ছে এই ডিস্টেন্সটা, সেটাকে আমি ড্র করলাম, ঠিক আছে? নাও আই হ্যাভ অলরেডি taken the projection in a plane in which one of the lines looks like a dot or could be projected into a single point, and on that plane I'm also projecting the second line. Now if the two lines intersect, the line that has been projected as a point would lie on the projection of the second line. যদি না হয়, if the point doesn't lie on the, that is, A and AB line is projected as a single point, right? If that point doesn't lie on the projection of CD, then the intersection is not there. বোঝা গেল এবার?
হ্যাঁ স্যার।
ওকে, তাহলে এইভাবে করতে পারবে সব প্রবলেমগুলো?
হ্যাঁ স্যার, ট্রাই করব।
হ্যাঁ স্যার।
স্যার তার মানে কোন দুটো লাইন ইন্টারসেক্ট করেছে কিনা মানে ওইটা আমরা এভাবে দেখবো।
এইভাবে চেক করতে পারো, হ্যাঁ।
ওকে স্যার।
ওকে, লাস্ট স্টেপটা বোঝা গেল তো? সো আই এম এসেনশিয়ালি প্রজেক্টিং ওয়ান অফ দ্য লাইন্স এজ এ পয়েন্ট। যদি এর মধ্যে যে সেকেন্ড লাইনটা রয়েছে সে যদি কোনো আলটিমেটলি কোনো যদি লাইনে প্রজেক্টেড হয়, that projected line should contain the projection of the other line which is now a point. If it doesn't contain, there is no intersection. If it does contain, then that point needs to be projected back to the horizontal and the vertical plane to get the coordinates. মানে যদি আমি এই অবধি আসার পরে দেখি যে সত্যি সত্যি এই পয়েন্টটা লাইজ অন দিস স্ট্রেট লাইন, then I'll have to project this line back, okay, first to this first auxiliary plane, then to the vertical plane, and then to the horizontal plane. Okay, so basically I'll be drawing perpendicular lines. So from here one perpendicular, from there another perpendicular, and then from there another perpendicular. Okay, in addition to that, if you can think of any other step to check whether or not there is an intersection, okay, so you can use your own justification, but you will have to justify that this is why there should be there is a point of intersection or there is not. Okay, so if you can think of any other method, that is also welcome. Okay, otherwise you can try this. বোঝা গেল এবার?
So this perpendicular would give us the point of intersection.
Yes. So if we want to get the coordinate of the point of intersection, okay, so we can project back from the second auxiliary plane to first auxiliary plane, then vertical plane, then the horizontal plane. That we can do.
Okay, sir.
Okay. In addition to this, I would also ask you to think of if there is a much simpler method in which you can also get the whether or not there is a point of intersection, and if there is, then what is the coordinate? Can you get that only from the front view and the top view without doing anything else? So that you should also check. Okay, so that is also an assignment, and I'll post the set of problems in the group. Okay, so I have nothing else to add, so unless you have any other queries, we can stop. কারোর কোনো প্রশ্ন নেই তো?
Sir, I have a general query. May I ask?
Yeah, sure.
Sir, I am asking that in our examination, will there be theoretical question also or just drawing?
আমি কিন্তু ঠিক জানি না তোমাদের ড্রয়িং এর কি সেশনাল মানে সেমিস্টার পরীক্ষা হয়। আহ, উম, আচ্ছা, আই থট ইউ আর অনলি ইভ্যালুয়েটেড বেসড অন ইউর ইউনো মানে কি বলবো, মানে ক্লাস পারফরমেন্স নাম্বার ওয়ান, অ্যান্ড মেবি আ ভাইভা অ্যাট দি এন্ড অফ দ্য সেমিস্টার। আমি ঠিক জানি না ইফ দের ইজ এ সেমিস্টার এক্সাম অর নট, সেটা আমাকে একটু চেক করতে হবে।
Okay, sir. I am also not sure about that.
ওকে।
Thank you, sir.
Thank you, sir.